Okay, so to keep score, that's kind of an important part of the game. We're going to do a couple of things. We're going to try to do this in as cleanly and elegantly as a way possible that hopefully will make a lot of sense. All right, so here in our game, we have this destroy apples button. Let's go ahead and clean that up, or at least we'll disable that button so that it's not there. Maybe we should, I'm going to go ahead. I'm going to destroy it. I'm going to delete it. Boom, delete, gone. All right, but I have added to my canvas a a piece of score text. Now that's like gore text, but not no. Anyway, let's move that somewhere useful on the scene so you can see it. And there it is. It says new text. Wonderful. Okay, so it's just a plain piece of canvas score up there. Nothing exciting on it. Let's save our project. I did that wrong last time. Got me into trouble. Okay, so in the game, I press play, start the game, and what happens? All right, focus well. I have apples, I have baskets, I can catch things. Last time around, I left it with 5 baskets. Why not? 5 baskets. And nothing happens when the baskets hit the apples, right? Except for that sound, right? We have that sound happening. So, that's an interesting thought. Okay, wherever that sound is happening, that swoosh sound, that is where the apples get caught by the basket. So, it might make sense to go ahead and make that where a score gets implemented. Okay, so let's see. Inside of chest behavior, on a collision, that is where that sound happens. Okay, that's one potential place. Put it right there. Now, alternatively, when the apple collides with the basket, that is when the apple gets destroyed. This is kind of interesting, okay? The chest behavior had the play on it, but the apple behavior is the thing that actually did the colliding also. So that collision is managed in 2 different ways. It has this the destruction of the apple object that it collided with, and it has the play. So these are potentially 2 different spots that we could do something to keep track. And oh, there's a spoiler there, right there. Okay, it could be in one of those 2. Up to you. Now, the key thing that we want to do, though, is we want to put, and let me tell you my reasoning for this. I'm going to put the score, I'm going to keep track of the score in the Apple Tree player. It could be in the scene, it could be in anything that really has, I could put it in the Apple, whatever. But it makes sense because each player or a player, or maybe we have multiple players, if you think logically about it just in terms of an overall design, we would say the player has a score. The score belongs to the player, right? So let's start there. We won't make the score its own object necessarily. We'll keep it with the player. All right. Now, the question becomes, how do we keep? Now, normally we would just say something simple. We would say, oh, okay, int score. That'll be something to keep track of. We just put a score there for the player, int score. And somehow that needs to be incremented, right? So somewhere there's this plus equals 1 to get that value. So maybe we put something in here that was a function called increment score, and it would just add 1 to that and do the right thing. All right, but let's be fancier than that. Let's look at some technique here. All right. Now, most of the time, what you want to have is you want to design an object here. We're going to have things called fields and properties. Okay, so the score is really a field. It is something. It's a field. It's an internal structure. It's a private thing that belongs to the player, and we want to give other things the ability to access that. So what we do, we typically will access that through through a property. We want fields are accessed through properties. So going along with this private int score, we would have something called a property. Public int, normally it would be called capitalized score. That's the sort of naming convention. So score, this capital score, will be the way to access this other score, right? This becomes an accessor. So how do you make this look like an accessor as opposed to just any other variable? You use curly braces to create some scope to it. And you'll see, let's see, what does it say? Property or indexer must have at least one accessor, right? And what did an accessor look like? Here's the simplest one, get. That is an accessor. If you use something equals score, you're using the accessor, right? If you say something plus equals score, you're using the accessor. If you say the score plus equals something, now that's interesting. If we said score plus equals 1, for example, that would involve an access of score, but we would also have to write the value back. So for that, we would have set. So you can have get and you can have set. You must have at least one accessor, but the setter is sort of optional. Okay, so this is the basic, most automatic. This is the automatic version, they say, right? It's just going to do a get, and it's going to internally say, okay, put this in the local. I believe it's going to, this is going to be the automatic version. It's going to keep track. You don't even have to declare this piece up here if you didn't want to. You can even say like equals 0, and that would automatically set up your accessor, your setter, your getter, and an initial value. Okay, but we're going to be a little bit more elaborate than that. So I'm going to get rid of this version. And instead, what I want to do is I want to put some code inside the getter and the setter, the accessor and the setter. Okay, so what I can do is say, all right, get will return my field, right? So return whatever this is currently set to. Even though this is private, I have a public accessor, right? That sort of ghosts that, well, doesn't ghost, sort of hides this, it encapsulates it. That's the right word, encapsulate. So this capital SCOR encapsulates the private and allows some controlled access to it. So if you want to get it, this is how you get it. Nothing really exciting goes on there in the getter. It just returns the value. However, I do want something special to happen inside of the setter. Right? Normally, you'd see something like set score equals value, and that's all it would do. That's kind of the default. This piece here is extra. Right? So if I said capital, if I said AppleTreePlayer.score, capital score equals 5, it would just go ahead and set that score to the value 5. But I can put code in here so that anytime basic operations, basic access and setting of this happen, that this will be enforced, right? So what's going to happen now, I said, all right, this is the perfect opportunity to say, score equals value, and then if the score is changed, I could say, right, I could have said if it was changed, or I'll just go ahead and assume that it's being changed. Not a terrible thing. Say, okay, assume that it's been changed, and what do I want to do? What I want to do in that case, I'm going to set the text of the score object to be the value converted to a string of score. Okay. Crazy, right? So anytime I were to say AppleTreePlayer.score equals something plus equals something divided by equals something, anything that involves the use of this score, and I set the value, I change the value, this is what's going to happen. Something more complex than just setting the value. It's going to also set the value of that interface element. Right? Save that. Now, so you don't see anything in here where it's setting the score necessarily, right? You could. Up front, we could say, all right, there should be an initialization here. So, and this is a little extra bit there. We could say score equals 0, or score equals 100. Right? So without changing anything, I haven't accessed this from anywhere except automagically. Come over here, I press play, and watch what happens if all goes well. It got set to 100. Right? Pretty seamless. All right, so that's one place I set score. I'm going to set score to a 0 there, because why not? And say I want to, and now we get back into this situation where, okay, apple behavior on collision, that's when when the apple hits a basket, we destroy the apple. So now let's look at how we would access a property of a class that is instantiated on another object. Right? There's a lot of words there, but this is a property of a class instantiated, or that is an element of that other game object. So game object dot player find, game object find dot player. That's finding the player object. And here, this reinforces, okay, our classes are just like any other component, so long as they are derived from a monobehavior. Right? Any class that's derived from a monobehavior can show up in here, right? Because it's part of that find. It all works. So we get that component, Apple Tree Player, and now we're free to change its property, score. Now we could also, if this was a function, we could call functions through this. If this wasn't a getter, setter, accessor, we could still do that, right? So this could have been, we might have had something that said add score or change score. That could have been a function. But this is kind of neat. I like this one because it's not just add. It's like any access and setting of score. And I could even do this. I could say score plus plus. Right? So now in our game, we'll come over here. And you'll see it'll start out, hopefully it's 0. And now every time I catch an apple, the score changes. Yay! All right? So without even thinking about it, I could do something like say, well, okay, I want to change the score, or what if all apples get destroyed, I should subtract from the score. Right? For some reason, we lost a life. Or, well, I could have had it there. I could have even had there. Apple Tree Player lose life. All right, whenever you lose a life, let's go to Apple Tree Behavior. Where is it? Lose life. Right? Wasn't this in here? Apple Tree Behaviors. Start. Change direction. Change. Drop apple. It's not in Tree Behavior. It's in Apple Tree Player. Duh. All right, here's lose life. Right here. Lose life. -1. All right. Score minus equals 10. What happened there? That's not what I wanted to have happen. Score. There we go. That was weird. Why is it complaining here? Static public int lose life. Oh, well, can't do that. Why can't we do that? Well, we did this weird thing where we said lose life and gain life were statics. Because we thought, okay, there's just one of those, so let's make it static. Right? Here's where it comes back to haunt us. All right. So we should make lose life. We don't want lose life to be static. We're going to say lose life is public. Now, that's going to cause a problem somewhere else. You'll see up here, okay, Apple Behavior.cs, an object reference is not, right? This is no longer valid, right? We cannot refer to lose life as being a method of the class, a static method of the class. Instead, we have to access it as a particular instance. Right, so now we find the instance of player called player, and we call lose life on it. Okay, so that's cool. Let's go to Apple Tree Player again, and we'll even clean this up. One more thing. Where was it? Lives left. Oh, well, okay. There's only 1 lives left. I don't know. We should really just make it lives left. And this is also using a getter and a setter. All right. So if we needed to do anything fancy with lives left, that's where it would be happening. And also the question would be like, oh, well, maybe we shouldn't make that basket array static either, because maybe we'll have multiple baskets for each player. We're thinking 2-player. Think 2-player. What the heck? You can do it. You can do it. I try to be a little dramatic when I'm talking here. People like it. All right, I'm catching the apples. Say I miss an apple, what's going to happen? Oh, minus 10 from my score. Brutal. Oh no, minus 10 from my score. All right. Now, there's always decisions to be made. You could always do things like say, well, okay, well, if the score was changed, that should be where you manage the number of baskets, perhaps. Maybe? No, not really. Because the score going up really has no impact on the number of baskets. Or does it? If you said, okay, well, if the score goes beyond 10, maybe you want to give them an added life. So, we could say, right in here, crazy now, see if this works, if score greater than, so no, let's say score equals 10, okay, if score equals 10, gain life. All right. Or, well, I'm going to leave it that way. What would you do? How would you do it if you wanted the score to be every time you gained 10? So 10, 20, 30, 40, you gained more life. Not just equals. You'd have to use a different thing. All right. So let's see what happens now. Can I get score? First I'm gonna like make sure I lose some. Oh, that's rough. I have to get 20. I have to get 30 here. Bear with me. Ugh. It's brutal. All right. How are you doing today? So we should create some conversation. Doing pretty good. I'm good at this game. All right, 10 more. 1, 2, 3. Almost there. Aha! Okay, you see? Let's see if I can get all the way to the top. Well, nope, still 4. Why didn't I get another one? Well, because I said equals 10, not the version that we need to get there. Now, you could also do things. Now, imagine you wanted to be in here. If score's there, you want to do da-da-da-da, announce it. You could do something in there. You wanted to flash the screen, you could do it in there, and so on and so on and so on. So, there we covered. All right, what did we cover? We covered getters and setters, fields, and properties, right? This is a field. This is the property. The way you access a field is through its property, right? And we also, if we looked at Apple behavior, we see, this is how we would access a method of another class, which is a component on another object. And potentially even here's how we would go ahead and use kind of invisibly, seamlessly, that accessor, setter, getter sort of construct there. Right? Lots of fun. Hopefully that provided some useful information. I think really now it's a matter of knitting together all the pieces. I can't imagine what else. Oh, we still have player prefs to talk about. We'll talk about that next time.